This is section 12.1 and we're going to be dealing with a sequence. A sequence is a function that's made up of terms, and we have some terminology here. We have a sub 1 is the title for the first term, and a sub n can be the last term. And so an example of what we might see, write the first 6 terms of the a sub n, that function that is this, n minus 1 over n. So what you want to do is kind of make a chart for yourself and let n be, say, 1 through 6. And then you're plugging these numbers into here. So if I plug in 1, I've got 1 minus 1 is 0, then that one's going to be 0. If I plug in 2, I've got 2 minus 1 is 1 over 2, that'd be 1/2. Plug in 3, 3 minus 1 is 2 over 3. So you do that all the way down and you would get your first 6 terms. This one says do the same thing, and it doesn't have to be a sub n, it can be b sub n. This is the description of the function. So you're raising negative 1 to the n plus 1 and times 2 over n. So if we plug in 1, negative 1 to the 1 plus 1, so that's 2. So negative 1 squared would be 1 times 2 over 1, so it'd be 1 times 2, you would get 2. And you would go through and get these. So it's plugging in and getting the values. So I've shown that here. Now, the next part is not quite as easy sometimes. We're determining a sequence from a pattern. So if you were given the pattern E, and then e squared over 2, e cubed over 3, e to the 4th over 4. You want to think it this way. You want to say, okay, if I let n be 1, 2, 3, 4, how did I get from 2 to be this? How did I get 3 to be this? And that one we could see that e to the n over n. E to the n over n. So e to the 4th over 4. All right, e to the 3rd over 3. All right, on this one, we got 1, 3, 5, 7. So we know those are odd numbers, but what we have to do is look again at n is 1, n is 2, n is 3, n is 4. How did I get to 1? And then how, when I'm 2, did I get to 3? And that one's a little bit harder to do, but 2 times this number plus 1. So if n is 2, 2 times n plus 1 gives you the number. So we're getting the next number when we do that. If n is 1, then 2 times n, 2 times 1 plus 1 gives me 3. And then 2 times 2 plus 1 gives me 5. 2 times 3 plus 1 would give me 7. All right, 1, 4, 9, 16, 25. When I see those, I think those are perfect squares. So when I write my 1, 2, 3, 4, 5 down here, I see that it is just n squared. So you won't have too many of those, but it's good to try to come up with the pattern. The next thing in the notes is factorial. There is a symbol, n factorial, and what that means is it's n times n minus 1 times n minus 2 till the end, till you get to the end. So 4 factorial would be 4, and then you just take away 1, times 3, times 2, times 1. When you get to 1, you're done. Now 18 factorial, you probably do not want to try to do that by hand, so we need to go to our calculator and see where that is located. So I've brought the calculator up here. So when you want to do factorial, you can hit math and then use your side arrow to go over to probability, and you'll notice it is number 4. And so you would hit your, if you're doing 18 factorial, you're going to type 18 first. So let me second quit out of that. I'm going to type 18, and then I'll do math, over to probability, and hit number 4. So now on our screen we've got 18 factorial, and we get this. Now, this is in scientific notation. It's a huge number. And this e to the 15 means this decimal is 15 places to the right. That's how it moves. So it's a huge, huge number. So that's what we would get. But let's do 4 factorial and see if we don't get what we're supposed to do there. That one was just a hard number to even recognize. So we'll do that. We'll go over to probability and then choose 4 and enter. And 24 is 4 times 3 times 2 times 1. So that is how we will do that. All right, so we're down here to recursive formulas. And we get, in these, we get an assigned value for the first term and an equation for the last term. And then you have to figure out some terms of the sequence. So they've given us S sub 1 is 1, S sub n is, and here's the recursive formula. So what you do is whatever, if we're doing n is 2, S of 2 equals 2 times, and we're going backwards 1, S sub n minus 1, so we're going back to S sub 1. So 2 times 1 is 2. And then as you can see with my arrows, this n equals 3, we've got 3 times whatever S sub 2 was, so that's the 2. So 3 times 2 is 6. The 6 goes there. 4 times 6 is 24. 24 goes there. And then 5 times 24 is 120. So what you're doing is they're giving you the first term. You figure out the second term by plugging the first term into wherever the S sub n minus 1 is going, and you get your terms. All right. Let's talk about summing of terms. Summation is when you have a sequence, but you want to know what is the sum of all those added up. And so this is a symbol for summation. K equals 1 at the bottom is where to start. A sub k, whatever is there, is the function, and n is where you're going to end up. And so we could do, let's go to this one. So if we had k equals 1 to 2k plus 5 over 20. So when k is 1, you would have 2 times 1 is 2 plus 5 is 7. And you would put 7 here. And you would go on till you get to 20. Well, that's some work there. So we can do these on the calculator. If you do not have the newest operating system, then you're going to use this. If you have like a TI-83, you're going to use this. You'll hit second stat. Let's do it. Let's bring the calculator up. Hold on. Okay, I think I've got both up here now. So if we did second, let me just clear this so we're not looking at anything else. Second and the stat key, and then we go over to math and choose number 5 because we're looking for sum. So we'll hit sum, and we're telling it we want the sum of a sequence. And then we'll do second stat again, and we will go to ops, operations, and we will choose 5 for sequence. And so on this calculator, it's the newer one. And so all you have to do is put the expression here. So you would put, let's do this one because we have the answer written here. Let's put negative 3x. Negative 3x. We come down here and we put the variable x. And we are going to start at 8. And we're going to end... we're going to end at 40. And I don't think we have to put anything for step. Let's paste. And we have that, which is what you would do if you had the old system. You would do exactly what I did, and then you would type in the function, comma x, comma the lower limit, comma the upper limit. And we'll hit enter, and we should get negative 2,376. So older, you're going to do this. For the newer versions, if we go to math and we go, I think we can go up, and there is summation, enter, and you can just put in your pieces there. We're going to say x equals 8, and we'll hit our right arrow. We'll go up there to 40, and then we'll go to here and put our negative 3x, and we hit enter, and we get the same thing. So if you have the brand new or a pretty new operating system, you may have the summation under math. If not, you've got to follow this. So keep that in mind as you're doing it. If you have the summation symbol, that's an easy way to do it. All right, so I think that covers our notes. Let's go look at our problems. So number 1, decide whether the following statement is true or false. The notation a sub 7 represents the 7th term of a sequence. That is true. The sequence a sub 1 is 7, and a sub n is 2a to the n minus 1, an example of a. That's recursive. Remember, that's the one where they give you the first, and then they give you a function, and that's what it's called, recursive. Number 3, a sub 1 plus a sub 2 plus a sub 3 all the way to a sub n, and then it shows you a symbol, is an example of that summation notation. So those first 3 are really kind of vocabulary and just going over definitions. Then number 4 and 5 are factorial, and remember we did that, and I've shown you the actual keystrokes here that you would hit. You hit 6, math, over to 4, where you hit math and enter, and then 4 is going to give you the factorial symbol and enter, and same way here with this one. So we did that. This one's 9 factorial divided by 6 factorial, so you would have to put the second one in parentheses. That would be important there. Write down the first 5 terms of this sequence, and the sequence is 9n. So if you let n be 1 through 5, then 9 times 1 is 9, and then 9 times 2, 18, etc. That one's pretty easy to do by hand. Write down the first 5 terms here. Now, you can do this by plugging in, if it's really easy, like we did it with number 6. You can also use your calculator to do a sequence. So let's look at the screen here. Let me make that a little bigger for a minute. So we did second stat, the keystrokes are here, and then we chose 5 for sequence and enter, and then you're going to put in the function, which is x over x plus 5, comma x, comma 1, comma 5, and you're going to hit enter, and it gave you this business. That's in decimals. They're expecting you to do this by fractions, so just hit math and the fraction key and enter. Well, that's the first one, so you'll just hit enter, and it gives you your answers right there. So you can do that completely on the calculator. All right. All right, let's look at number 8. And let me make this one back smaller. All right, number 8. The sequence is -1 to the n times n squared. So again, we did second, we did second stat 5, and then we had a parentheses. We're going to do -1 to the x, close, times x squared, close, because that's the whole function. It needs to be in parentheses because it's kind of complicated. And then comma x, comma 1, comma 5, hit enter, and you get your numbers, and they're not decimals, and we're good, for that one is good. All right, let's do number 9. This is the sequence, definitely complicated, and again, you can do that by hand. You can plug in 1, 2, 3, 4, 5, but this is pretty easy. So second stat, choose 5, and you're going to get sequence, and then you're going to put in -1 to the x divided by, put a parentheses, and then another parentheses for x plus 5, close, second parentheses for x plus 1, close, and a final one, comma, x, comma, and if it went on, we would have, we just hit enter there. And so we just needed 5. Hold on. We aren't seeing it, but it would be comma 1, comma 5, because we need the first 5 of these, so you just can't see it on that screen. And then you got decimals. We said change it to fraction, and we got our answers. So that should be pretty clear on those. Let's look at number 10. So on number 10, you're given a pattern, and they're wanting you to come up with the sequence, what it should be. So if you think about the chart and we let n be 1, 2, 3, 4, how did we get to the bottom, and what is the pattern that we're seeing? 1 plus 11 gives us 12. 2 plus 11 gives us 13. 3 plus 11. So determinant, that is just, I don't know what that is. This should be an 11. Don't know what that was. So determine that the denominator is n plus 11 in each case. Let's look at number 11. Okay, a sequence is defined recursively. Write the first 5 terms. So a sub 1 is 4. A sub 2, you're going to use n is 2 in the formula. And so you have a sub 2 is 1 plus a sub 1. And a sub 1 was 4, so that's 1 plus 4 is 5. A sub 3 is 1 plus a sub 2. You're building, so 1 plus 5 is 6. That 6 goes there. 1 plus 6 is 7. That 7 goes there. 1 plus 7 is 8, and that's how you build it. Let's look at number 12. Same idea. A sub 1 is negative 8. So a sub 2, here's our function, 2 minus whatever a sub 1 was. So that's a positive 10. A sub 3 is 3 minus whatever a sub 2 was, which was 10. That gives us a negative 7. Negative 7 goes there, so we have 4 plus 7, that's an 11. And then 5 minus 11 is negative 6. So you're just building. The numbers you get go in the next item. Number 13, we are writing out the sum. And if we start at 0 and go to n, they want you to do 3 ... and then write the just general expression. So this first one, we have 1 over 8 to the 0, because we're starting at 0, so that'd just be 1. 1 over 8 to the first is 1 over 8. 1 over 8 to the second is 64. ... 1 over 8 to the n. Okay? All right, let's look at number 14. Well, let's look at 14. So the function is 1 over 8 to the k plus 1. And we can pretty much write those terms out by hand. So this is 1 over 8 to the 0 plus 1. So that is just 8 to the 0. That's just 8 to the first. So that's 1 over 8. 8 to the 1 plus 1 is 8 squared. So that's 1 over 64. 1 over 8 to the 2 plus 1 is 8 cubed. That's 1 over 512. And then the last one is you put the general thing, and instead of k, you're going to put an n. Number 15, you can use the summation icon under math, or the sum sequence that I showed you in the notes. And so you're just going to put in 1, 17 of 5, you get 85. This one, it's just k, 1 to 47. The sum of that would be 1128. From 1 to 4, k squared minus 6 gives you 6. So there's 17 questions in the set, but some of them are very quick calculator items, and they should not be too bad. I hope that'll get you through 12-1.